Can you guys see my screen?
Yep. And
Okay.
Han, notice the California flag in the background?
Yes, I did.
Okay, so let's get started. First of all, it's a pleasure to be here today to demonstrate the new relay. As Bob mentioned before, we built this new relay because the current Almaden relay is compatible only with Windows and Linux agents. So what we want is having a single application capable of to receive and forward data from any kind of agent, Windows, Linux, macOS, yada, yada, yada. So this is the new relay interface. I think it will be easier to demonstrate the relay using its interface. So here we have the connection list, and here we can see all connections that was created with our relay, okay? And here we can see, for example, the connection status, if the connection is alive or dead, the downstream IP address, which is the client IP address, the upstream IP address, which is the final endpoint IP address. And here we can see if the client is a device running Windows, Linux, or macOS. And the last column is the exact time when the connection was opened, okay? And here we have two more sections. This first one is the transmission data, and the second one is the HTTP requests. So in the transmission data section, we have a lot of useful information. For example, we can see how many bytes was read from downstream, and how many bytes was reading to upstream, and how many bytes was reading to secondary endpoints. We also can see how many bytes was read from upstream and how many bytes was reading to downstream to the client. And in the section called HTTP requests, I don't know if you guys know this, but it's totally possible to make more than one HTTP request using a single TCP connection. So we can see all HTTP requests has been sent through this TCP connection, and we can see useful information like the method, the route, the request headers, and here we can see the original headers has been sent to relay and what HTTP headers the relay forwarded to the final endpoint. Here we can also see the response readers, the response HTTP readers, the exact moment when the request has been sent, and the exact moment when the HTTP request has been replied, the HTTP status, and the HTTP request duration. And basically that's it. It's a pretty simple, but I think it's a lot useful.
Thank you. So a lot has gone into this, not just making the relay work, but then we had to add TLS security to it, and of course we needed a UI. We did not leverage Natalia for design work on the UI because this really is used by very few people. If anything, we needed something that support could work with, so if a customer has an issue, they could effectively trace packets and figure out what transpired. But I think it came out very nice and clean. Gabriel's done a lot of work on this. He's done literally everything, start to finish, on the relay. I expect that this will be in QA next week. So just, some additional testing to be done. And right now, Nico's testing an issue that we had found with Windows. And once we have that resolved, then I think we'll be ready for QA. And this is also being tested with the new agents because that's really the timing when this will come out. So, any questions?
So the TLS security presumably only works with the new agents.
Yeah, it's totally possible to customize. You can add the TLS layer between the client and the relay, and between the relay and the final endpoint. So if you want to use TLS only between the relay and the final endpoint and let the device using TCP only with the relay, it's totally possible. In this case,
that's good.
Right, but the point, though, really, Peter, is that we should use this with the new agents because it should be the timing.
Yeah.
But it means that we can, even if customers haven't updated the agent but are using the new relay, that the piece between the relay and the receiver can all use TLS.
That's I don't know about Windows and Linux agent, but in order this relay work, I think we must change some things on the macOS agent, because, for example, relay can use TLS, but he needs a certificate. So we can change the macOS agent code to trust this relay certificate.
Well, we won't have to worry about the Mac agents, and we can tell people again to upgrade. There are not that many Mac agents out there anyway.
Okay, but
it's more a question for Windows.
Yeah, but does this mean that we're going to have to push new security certificates to people occasionally?
No, I don't think so. It will be necessary.
Okay, so where are the certificates going to come from?
I mean, the current relay already is already using TLS. No.
Mm-hmm.
So we can use the same certificate, I think.
Okay. But yeah, looks really good. So normally in here, we would see lots of different devices connecting. Is that correct?
Yeah.
So in the downstream part, we would have, the hundreds of IP addresses within the customer infrastructure.
Yeah, and if we use this relay in huge customers, I think it would be a lot of connections here.
Yeah.
But I talked with Bob. I think we keep data for something like 7 days, maybe. Is that right, Bob?
Yes.
7 days.
Is your concern about the data retention period, Peter, or about the block there that shows the agents and the fact that it's like a dozen, and that'd be constantly needing to be refreshed if you're wanting to keep track of all of them?
Yeah, I mean, most of the time they're not going to have the UI open, so that's not an issue. But they would see. So normally, if we've got 100 agents connected, the downstream IP addresses would be 100 different IP addresses from those agents. Is that correct?
Yeah, that's right. Absolutely right.
And there's a search built into that. So if you wanted to check a particular agent, you could look up the device.
Yeah. Assuming you know its IP address. So this will work with multiple receivers, because I see you've got primary endpoint and secondary endpoint. So is this going to give us the ability to either load balance and fail over, or?
Okay, let me explain this. I think it would be better if I open the documentation, maybe. Just give me a second, please.
No, that's no problem. But looks really good. Nice, clean user interface.
Let me see.
He's been working on the documentation in parallel, Peter. You'd be happy about that.
Yeah. Lucky chap. Yeah.
I have the documentation as well.
But I want to open this on Draw.io because I can zoom in and zoom out. I think it will be better this way to explain to Peter why we have secondary endpoints and stuff like that. I think this is the file.
Okay. As you say, even with PDF, you can zoom, or at least on the Mac, you can.
Yeah, so basically the new relay is just a TCP tunnel.
Mm-hmm.
So you can create more than one TCP tunnels for different receivers. So we're gonna make something like for example, we have two TCP tunnels here. We can do something like, this first tunnel will send data to the macOS receiver, and the second tunnel we send data to Windows receiver. This way. And why we have secondary endpoints? Because, for example, here on Almaden, we can create a TCP tunnel that sends data to macOS receiver on dev environment. And the secondary endpoint will be the macOS receiver, but staging environment, for example. So it's totally possible to one single device report data to dev and staging environments.
Okay, so it's not for failover, but within the infrastructure.
It's important to pay attention to this. The proxying between these devices and the primary endpoint is a full duplex proxying, which means the data replied by the primary endpoint will be forwarded to this device. But the data replied by this secondary endpoint will never be forwarded to these devices.
Okay, yeah.
But I think what Peter's really asking is, can an environment, like let's say Lab 2, have multiple receivers and the relay be able to send to both of those receivers? And that way, if there were a failure, there would still be one receiver working.
Yeah, I think it's totally possible. For example, you can configure to the primary endpoint to be the first receiver and the secondary endpoint to be the secondary receiver from LAD 2. Is that it? Is that right?
Yeah, that's what I was asking.
Yeah, for example, LAD 2 receiver macOS 1 and LAD 2 receiver macOS 2.
Yeah.
Right. So with that one, then that way you do have resiliency.
Yeah. Yeah, it's totally
That's
possible.
what Peter was really interested in.
Okay.
Yeah, we've got sort of zone level resilience in the infrastructure. So if it fails in one data center, it will automatically fail over to a different POP within the same zone anyway at an infrastructure level. But obviously, as you know, we have multiple receivers at the moment anyway.
Oh, got it. Okay.
Yeah. No, that's good.
Any more questions?
So, and did you implement the queue that you had discussed the other day?
Yeah, the SQLite queue, yeah. I think here. So when the TCP relay is proxying data from the client to the final endpoint, he also writes useful information in a shared memory region.
Mm-hmm.
And all that data here, this connection list, is being stored in an SQLite database. But
Okay.
it would be bad if we just wait for write operations. So we create this SQLite write queue,
Mm-hmm.
and we push write operations to this queue, and a separate thread can watch this queue and write to the local database.
Yeah.
But that's it.
Yeah.
Okay.
So Gabrielle did performance testing also during the week. And that's where, we found that performance degraded significantly waiting for writes to occur. And so with the queue, we avoid that problem.
Yeah.
And as he said, we'll store data for 1 week. That should be more than adequate for troubleshooting. Yep. Otherwise, there's no purpose to store data.
No.
As Bob mentioned, I ran some tests, some performance tests. The first one was using a local HTTP server on my device. Mm-hmm. And the second one was using the Almaden HTTP receiver, Almaden macOS receiver.
Yeah.
So here we can see some numbers like the number of requisitions per second without the Almaden TCP relay was 50% of the time was 687, and using the Almaden TCP relay was something like 682. And this is great because it's basically a transparent proxy.
Yeah. And the macOS receiver should be more efficient anyway than the Windows receiver.
I think so. Yeah.
Because it just uses it just dumps it to an SQS queue.
Yeah, absolutely. And the macOS receiver was built using Go. Yeah. So it's pretty more efficient. You're absolutely right about that.
I've no idea what the throughput on the Windows receiver is.
Me neither.
Cool.
Yeah. But I mean, if you're getting a 99.3% throughput on a relay, that's amazing.
Yeah.
That's what we expected. Almaden is amazing.
Yeah.
All right. Cool. Well, if there's nothing else, we'll let Gabriel get back to finishing this. And then, as I said, we want to get it into QA. And otherwise, you've got agent testing going on, particularly for Windows. And I'm expecting that next week we'll release new Windows agents.
Yeah. That's
good. Great job, Gabriel. Yeah. Thank you very much.
Thanks very much.
Good job,
you guys.
Great job presenting too.
A little bit nervous, but I think I managed to explain to you guys.
You didn't come across as nervous at all. It was really good. Thank you.
Thank you, Peter.
Yeah, English was great.
Getting better.
Okay. Thank you. Bye-bye.
Bye bye, guys.
Bye.